Welcome back. We want to continue our discussion about circle geometry. Uh, Here you have circle geometry. As I told you earlier, circle geometry is very simple. You only follow some theorem and principle. Once you mind those theorems as I've been putting effort to you, there's no circle geometry you cannot solve. So just follow again. Here you have here we want to prove another theorem which we call alternate segment. Alternate segment. Now, here you have alternate segment. I told you about segment the other time. Now, here you have a circle. Then, in the circle, there is a tangent. This is what you call tangent. A line that touches the circle. So, if you can just label it, maybe you can label this one as PQRX. Then, it alternate segment. Earlier, as I told you, we divided the circle into two equal parts. We have minor segment and major segment. Then, what we want to prove is that the angle between alternate segments, they are equal. This is an angle here. Maybe you can just call this one A1. This angle here. This angle between a chord. This is a chord. Maybe you call this chord PQRX. You call this one X. We have this angle now. We want to prove that this angle is equal to any angle that the remaining parts of this the remaining part of this circumference subtend, like this. You have something like this, or you have something like this. Now you can call this one, let's call this one A2, A3. Now, what do you want to prove? We want to prove that this angle here are equal to this. So what are you given? So you can say given a circle with tangent P, Q, R and chord Q, X. I see. So you have this what you are given. You are given a circle with tangent PQR and chord this. Then to prove PQRSTU, let's have it like that. Then construction. What do you want to construct? Let's construct a diameter. Construct a diameter from the tangent Q joining TX. Now, what you want here is this. You want to construct a diameter here that will join this line here. So you call this one V. So then join it with this. So you construct that's a diameter from the tangent Q. This is it. And then join with X, joining X. So you simply join it with X here. Then That's it. Or you can say x or vx. So you just simply produce this one. Now look, let's label this place. Let's call this one y1. Let's call this one y2. All right, we labeled it. Then what do you want to prove? Prove, prove that the angle between a tangent, the angle between the tangent and a chord, angle between the tangent and a chord is equal to any angle subtend at any point of the remaining part of the circumference. So this is what they have to prove. Prove that the angle between a target and a chord, this is a chord, or chord is equal to any angle subtend at any part of the remaining part of the circumference. This is the remaining part of the circumference. This minor arc, minor segment and major segment. Then let's prove now. So you don't need to cram anything. It's very simple. So look, angle A plus Y. That is, you may not do it like that. You can anyhow. I can say that angle RQX. That is angle RQX, which is A, plus angle SQV, angle SQV equal to 90 degrees. What's the reason here? That's the perpendicular uh, tangent, the perpendicular line tangent to PQR. So to the tangent PQR, this is it. This perpendicular line, here you have this diameter. So you have that one as what center O. So if you have a perpendicular like this, this perpendicular line. So this part is 90 degrees, while the other part is also 90 degrees. Therefore, what you have here is A plus Y1 equal to 90 degrees. So you have that. Again, look at another thing. Look here. This is diameter. That's so that this place is angle. This place is angle at the semicircle. We have proved that angle at the semicircle is 90 degrees. Since this is 90 degrees, it means this y1 and y2, they are equally 90 degrees. So you can say that angle xq, that's sqv, plus angle svq equal to 90 degrees. That's complementary angle, complementary angle of angle of angle at angle at a semicircle QVX. That's it. When you add two angles together and it give you 90, you call it complementary angle. So you can now have y1. So that's the proof. Y1 plus what? Y2 equal to 90 degree. Now look again. This is 90 degree. This is 90 degree. So 90 is equal to 90. Therefore, since 90 degree equal to 90 degree, then y1 plus y2 equal to a1 plus y1. a1 plus y1. Then look, if you take this y to the other side, you have y2 equal to a1 plus y1 minus y1. This is equal to what? This minus this is 0. So you have it like that. Now look, what we have done now is that we have shown that this angle here, this A equal to y2. And so you have proved it. And what it says that is equal to any angle in any part of the remaining circumference. So this y2, you can say that y2 equal to a3 equal to a2. So they are, and then they are what? Angle at the same segment. So angle at the same segment, we prove it before, they are equal. So we have proved it. So